Good morning. Today I'm going to go over graphing exoplanets, Kepler. And what we're talking about is the Kepler Space Telescope, because there were studies looking for exoplanets before the Kepler Space Telescope, and they were partially successful. But then this Kepler Space Telescope was hugely successful in finding exoplanets, added thousands of exoplanets to our known catalog. So there was kind of before and after Kepler. Now before, we tend to see larger planets like gas giants. But Kepler was so sensitive that after Kepler, using Kepler, we were able to find and identify smaller planets, more Earth-like planets, at least size-wise, orbiting other star systems. So we're going to graph some information here. We've got two different sets of data. So I'm going to use a colored pencil to distinguish these. So for this data here, I'm going to use red to graph it. And for this data with Kepler, I'm going to use this blue. So even if you can use pencil and pen, just two different things to distinguish the sets of data, because you're going to see a pattern that'll form. We're going to take a look at this page here, and we want to start numbering 1 to 20. And what this is the size of the planet, the size of the exoplanet relative to Earth. So if it's at a 2, that means it's 2 times the size of Earth. If it's 1, that means it's the same size as Earth. All right, then on the bottom, we're also doing 1 through 10. And this is the orbital period. So this is how long it takes to orbit the star that it's going around. And you'll notice that these are all very short, a number of days, because most of the exoplanets that we find are actually very close to the stars. It's easier to find those planets. And now what we want to do is start to graph some of these. So I'm going to graph a couple of these before Kepler using my red pen. So size relative to Earth is 10, orbital period is 1. So I got 1, 10. I just place my dot. Let's do 3 of these total. Size relative to Earth 11 and orbital period 9. So here's 11 and 9 right there. And then 5 and 7. So 5 and 7. And you're going to finish up and you're going to graph the rest of these. Now I'll do a couple from Kepler using my blue. And it's going to be on the same graph, so we can see the data side by side. So now we have relative size of 1, orbital period 10. We have 5 and 9, so 5 and 9. We have 6 and 5, which is right there. And you're going to do the same thing. Do the rest of these, plot the rest of these data points, and you should see a pattern emerge from what we were able to find before Kepler and what we were able to find with Kepler. If you have any questions, let me know. Thank you very much.